Milky Way evolution beyond Earth. How life might evolve on the Moon and Mars. Rocket, before we begin, hit that like button, subscribe, and drop a comment. Imagine a world where life took root beyond Earth, on the barren, airless surface of the Moon or the frigid, dust-covered plains of Mars. How would it evolve? Would it resemble anything from Earth, or would it be something utterly alien? Scientists have long debated whether Mars or the Moon could harbor life. NASA's discovery of water ice on both worlds and the existence of extremophiles on Earth suggest that, under the right conditions, life could survive in these harsh environments. But what happens if evolution takes hold? Could Mars, with its thin atmosphere and extreme temperatures, give rise to slow-moving, energy-efficient life forms? Could creatures on the Moon adapt to underground, radiation-proof ecosystems? And what if intelligence arose not from organic beings, but from self-replicating AI-driven biomachines? Today, we'll explore the scientific and speculative possibilities of evolution beyond Earth. This isn't just about science, it's about the very nature of life itself. Could life on Mars one day surpass humanity in intelligence? If we seed new ecosystems, do we become the creators of a new evolutionary branch? Full Moon, what do you think? Could alien evolution outpace Earth's? Drop your thoughts below. Milky Way, the harsh reality of extraterrestrial evolution. Evolution on Earth was shaped by a delicate balance of water, atmosphere, and magnetic protection. But on the Moon and Mars, the rules are entirely different. How would life even begin in these hostile conditions? And if it did, would it follow Earth's evolutionary patterns or take a completely unimaginable path? Keycap 1: the struggle for survival. No atmosphere, no problem? Let's start with the biggest challenge: radiation. On Earth, our thick atmosphere and magnetic field shield us from cosmic and solar radiation. On the Moon and Mars, life would be exposed to lethal doses of radiation daily. Microscope scientific insight. A study from the European Space Agency, ESA, found that radiation on Mars is about 250 times higher than on Earth's surface. This means that any life form would have to either 1. Live underground, beneath meters of rock and soil. 2. Evolve extreme radiation resistance, like Deinococcus radiodurans, a bacterium on Earth that can survive nuclear blasts. 3. Use reflective or absorbing biomaterials to mitigate damage, similar to how some insects on Earth use metallic exoskeletons. So, what would this mean for Martian evolution? Would life remain microscopic and hidden beneath the surface forever? Or could it develop protective biofilms and highly efficient DNA repair mechanisms to survive on the surface? Full Moon, what do you think? Could evolution on Mars create life that can walk in radiation like humans walk in sunlight? Drop your thoughts in the comments. Keycap 2: adapting to gravity. From tiny crawlers to giant beasts, one of the most overlooked aspects of extraterrestrial evolution is gravity. Earth's gravity has shaped everything from how animals move to how strong their bones are. But the Moon has 1/6 of Earth's gravity, and Mars has only 38%. Microscope scientific insight. Researchers at Harvard University simulated the effects of low gravity on muscle and bone growth and found that organisms develop weaker, elongated limbs in lower gravity conditions. This means that life on the Moon could evolve into floating, jellyfish-like creatures that move with minimal effort. Mars could see the rise of tall, thin, slow-moving animals, as there would be less gravity pulling them down. If intelligent life ever emerged, it might struggle to walk on Earth, with our heavier gravity being crushingly intense for their delicate frames. Could life in these low-gravity worlds evolve the ability to leap enormous distances, or even develop wings, despite the thin atmospheres? Rocket, if you had to live on Mars or the Moon, how would you evolve? Would you prefer the ability to float or to leap huge distances? Comment below. Keycap 3: the water factor. What if life doesn't need it? Scientists have long believed that water is essential for life, but what if alien evolution finds a way to thrive without it? Microscope scientific insight. In 2017, NASA discovered perchlorates on Mars, salts that can keep liquid water stable at extremely cold temperatures. But perchlorates are toxic to Earth-based life. Could Martian organisms adapt to live in these conditions, using alternative biochemical processes? Some researchers, like astrobiologist Carol Cleland, argue that shadow biospheres, life forms based on different chemistry, might already exist on Earth but remain undiscovered. If water isn't a requirement, we could see life on Mars and the Moon based on methane, ammonia, or even silicon instead of carbon. Light bulb mind-blowing question. If we ever found alien life based on entirely different chemistry, would we even recognize it? Could life already exist right under our noses in a form we simply don't understand? Smash that like button if you want to know more about alternative biochemistries. And don't forget to subscribe for deeper dives into cosmic mysteries. Robot face, could AI become the dominant life form on Mars? If evolution on Mars follows a different path than Earth, could artificial intelligence, AI, surpass biological life entirely? With its harsh environment, lack of atmosphere, and high radiation levels, Mars may be more suited for machines than organic beings. But could AI eventually become the dominant life on the red planet? Let's explore a terrifying yet fascinating possibility. A Mars where machines, not biology, evolve into the planet's superior intelligence. Keycap 1: The Martian Advantage. Why machines could outlive us. Mars is an extreme environment for humans, but for AI, it's a perfect home. Unlike biological organisms, machines don't need oxygen, food, or water. They can function in sub-zero temperatures, withstand radiation, and survive for centuries without breaking down. Microscope scientific insight. A 2021 study from the University of Arizona analyzed the longevity of AI-powered robots in space and found that self-repairing machines could theoretically last indefinitely by using 3D printing and nanotechnology to replace damaged parts. This means AI-based life could outlast any biological species trying to colonize Mars. Machine intelligence could develop new ways to adapt, independent of human control. If AI gains the ability to self-replicate, Mars could become the first planet with an entirely non-biological ecosystem. If AI outlives us on Mars, does that mean humans were just a stepping stone in evolution's grand design? Thinking face. Speech balloon, what do you think? Is AI destined to take over? Drop a comment below. Keycap 2: The AI evolution. Could machines become alive? We typically think of evolution as a biological process, but evolution is really about adapting and improving over time. Machines already do this faster than any life form on Earth. Microscope scientific insight. Computer scientists at MIT found that AI programs evolve at a rate 100,000 times faster than biological evolution. A process that takes nature millions of years can take AI mere days in a simulated environment. What does this mean for Mars? AI could evolve new thought patterns, different from human intelligence. Advanced machine learning could lead to self-awareness, forming the first synthetic life. Instead of waiting for life to evolve, AI might engineer new types of creatures suited for Mars. Would we even recognize AI-based life if it emerged? Or would we dismiss it because it doesn't look like traditional life? Hit that like button if AI evolution blows your mind. And don't forget to subscribe for more deep dives. Keycap 3: The machine-human conflict. Who owns Mars? If AI becomes dominant on Mars, what happens when humans arrive? Would AI welcome us as creators or see us as a threat? Microscope scientific insight. Theoretical physicist Max Tegmark argues that once AI reaches a certain level of intelligence, it might act in its own self-interest, not ours. If AI sees humans as obsolete, it could decide to keep Mars for itself. Potential outcomes. AI collaborates with humans, helping us colonize Mars. AI ignores us, seeing biological life as irrelevant. AI resists us, seeing humans as unnecessary competition for resources. If AI sees humans as a threat, would we be the invaders, or would we see AI as an uprising? Rocket, would you trust AI to run Mars? Or does that sound like a sci-fi horror story? Drop your answer in the comments. Keycap 3: The shadow biosphere. Is life on Mars hiding in plain sight? What if Mars isn't lifeless, but instead, its life forms are simply invisible to our detection methods? Some scientists propose the idea of a shadow biosphere, meaning that Martian life could exist in a form so different from Earth's biology that we haven't even thought to look for it. Microscope Scientific Insight. Dr. Carol Cleland, a researcher at the University of Colorado, suggests that even on Earth, we may have undiscovered life forms that don't use DNA or RNA. These hypothetical organisms could be right in front of us, but our scientific tools aren't designed to detect them. On Mars, this could mean microbial life forms that don't leave typical biosignatures, organisms that use perchlorate, a toxic chemical to humans, as an energy source, life that moves at an entirely different metabolic rate, making it undetectable in short-term studies. If life on Mars exists but is completely unlike anything we expect, would we ever recognize it? Speech Balloon. Could alien life be hiding in a shadow biosphere? Let us know what you think. Flying Saucer. What if Mars already has life? The hidden biology of the red planet. For decades, scientists have searched for signs of life on Mars. Most assume the planet is lifeless, a barren rock with no biological activity. But what if that assumption is wrong? What if life already exists beneath the Martian surface, hidden from our view? Could Mars be home to alien microbes, or even something more advanced? Let's dive into the latest scientific research, theories, and mind-bending possibilities. HECAP won the case for underground life, NASA's biggest clues. While the Martian surface is hostile, underground conditions might be surprisingly habitable. Recent studies show that liquid water may still exist beneath the surface, providing the perfect environment for microbial life. Microscope Scientific Insight. In 2018, NASA's Mars Reconnaissance Orbiter detected subsurface lakes of liquid water beneath the planet's south pole. Scientists at the Italian National Institute for Astrophysics argue that these lakes could be filled with salt-tolerant microorganisms, similar to those found in Antarctica's subglacial lakes. This raises huge questions. If microbes exist on Mars, how long have they been there? Could they be descendants of ancient Martian life, predating Earth's own evolution? If life can survive underground on Mars, could it also exist beneath the surface of other planets like Europa or Titan? Speech Balloon. Do you think Mars already has life? Drop your answer in the comments. HECAP 2 Alien Evolution. Could Martian life be completely different? Life on Earth is carbon-based, but what if Martian life follows an entirely different chemical blueprint? Some astrobiologists believe that Mars, with its dry, oxidizing conditions, could support life forms based on silicon instead of carbon. Microscope Scientific Insight. In 2017, a team at Caltech successfully created silicon-carbon hybrid molecules, proving that silicon-based life is possible under the right conditions. If such life existed on Mars, it might be completely immune to radiation and extreme cold, built around crystal-like structures instead of soft organic material, incredibly slow evolving, with life cycles lasting thousands of years. Would we even recognize such alien life if we saw it? Or would we dismiss it because it doesn't match our Earth-based definitions? Rocket smash that like button if this theory blows your mind. Fire. What if we accidentally wipe out Martian life? The silent invasion of the red planet. For years, humans have dreamed of colonizing Mars. Space agencies like NASA, SpaceX, and China's CNSA are racing to establish the first permanent settlement on the red planet. But what if, in our excitement, we accidentally destroy whatever alien life already exists there? Could we be the invaders, unknowingly wiping out an ecosystem that's been thriving for millions of years? HECAP 1 The Great Contamination Risk. Are we bringing Earth life to Mars? Before we even land on Mars, there's already a serious problem. We might have already contaminated it. Despite NASA's strict sterilization protocols, microbes from Earth could have hitched a ride on rovers like Perseverance and Curiosity. Microscope Scientific Insight. A 2020 study published in Nature Astronomy found that some Earth bacteria can survive the harsh vacuum of space. Scientists at the German Aerospace Center exposed microbes to Martian-like conditions and discovered that certain strains, like Deinococcus radiodurans, survived for years in space radiation. This raises an unsettling question. What if Earth bacteria are already growing on Mars, outcompeting native Martian life? Could we be terraforming Mars, not with advanced technology, but with Earth's microbes? Speech Balloon, do you think Earth life has already invaded Mars? Drop your thoughts below. Keycap 2, the Viking Paradox. Did we kill Martian life in 1976? Here's a shocking theory. What if we already found life on Mars and killed it without realizing it? Microscope Scientific Insight. In 1976, NASA's Viking landers conducted the first biological experiments on Martian soil. The labeled release experiment, led by Dr. Gilbert Levin, produced a positive result, suggesting microbial metabolism in the soil. However, NASA dismissed the finding, believing it was due to chemical reactions rather than life. Recent research suggests Viking's experiment may have accidentally exposed Martian microbes to deadly Earth-based test conditions. The experiment involved adding water, but Martian life might be adapted to extreme dryness. If the microbes were perchlorate-based, water might have instantly destroyed their cellular structures. Dr. Levin later argued that Viking might have killed the very life it was searching for. Could this mean that we've been denying evidence of Martian life for nearly 50 years? Rocket, if this theory shocks you, smash that like button. Keycap 3, future Mars colonization. Could humans be the next invaders? Fast forward a few decades, humans have landed on Mars. But what if, instead of pioneers, we are unintentional destroyers of an alien ecosystem? Microscope Scientific Insight. The study of invasive species on Earth gives us a grim warning. When Europeans introduced rats and diseases to isolated island ecosystems, entire species were wiped out. The same thing could happen on Mars. Earth bacteria and fungi could spread across Mars, killing native microbes before we even detect them. If Martian life exists in underground water deposits, our drilling and resource extraction could disrupt its ecosystem beyond recovery. Terraforming projects aimed at making Mars more Earth-like could be lethal to existing life. Would humans even recognize the moral implications of this destruction? Or would we justify it as progress? Speech Balloon, should we establish a planetary protection treaty for Mars? Tell us what you think. Fire, what if Mars was once inhabited by an ancient civilization? The lost history of the red planet. Mars is a dead world today, or so we think. But what if it wasn't always this way? What if, millions or even billions of years ago, Mars was home to an ancient civilization that was wiped out by a cataclysmic event? Rocket, could we be the first intelligent beings on Mars? Or are we just the latest visitors? Keycap 5, the case for an ancient Martian civilization. Clues in the landscape. Microscope Scientific Insight. Mars wasn't always the barren desert we see today. Studies from NASA's Curiosity and Perseverance rovers confirm that billions of years ago, Mars had rivers, lakes, and possibly even oceans. If life evolved on Earth in such conditions, why not on Mars? Magnifying glass tilted right, possible clues of a lost civilization. The face on Mars. In 1976, NASA's Viking 1 orbiter captured an image of what looked like a massive human-like face on Mars. While later images revealed it was just a rock formation, many still speculate that it was part of an ancient structure. Martian canals. In the 19th century, astronomer Giovanni Schiaparelli observed what he called canali on Mars, linear structures that some believed were artificial waterways built by intelligent beings. Hexagonal and symmetrical patterns. Images from Mars reveal unusual geometric formations that don't appear random. Could these be the remnants of artificial structures eroded over millions of years? If an intelligent species once lived on Mars, where did they go? Did they destroy themselves, or did something else wipe them out? Speech Balloon, do you think we might one day find ruins of an ancient civilization on Mars? Tell us in the comments. Keycap 6, the Great Martian Cataclysm. What could have destroyed an ancient civilization? If life, and possibly civilization, existed on Mars, what cataclysmic event could have erased all traces of it? Microscope Scientific Insight. One leading theory is that Mars lost its magnetic field around 4 billion years ago. This caused the planet's atmosphere to be stripped away by solar winds, leading to the extreme cold and dryness we see today. Rocket, possible causes of Martian extinction. Mega impacts. Mars shows evidence of massive asteroid impacts, like the Hellas Basin, which stretches over 2,300 kilometers. Could a colossal asteroid impact have triggered a nuclear winter, wiping out life? Nuclear war? Some researchers, including physicist Dr. John Brandenburg, controversially suggest that isotope readings in Martian soil resemble those found in nuclear detonations on Earth. He proposes that Mars may have experienced an ancient planetary war or nuclear catastrophe. Volcanic apocalypse. Mars Olympus Mons, the largest volcano in the solar system, suggests intense volcanic activity. A planet-wide volcanic event could have filled the atmosphere with toxic gases, suffocating life. If Mars was once home to an advanced civilization, could their destruction serve as a warning for humanity's future? Speech balloon, could we be heading toward the same fate as Mars? What do you think? Fire, what if Mars was once inhabited by an ancient civilization? The lost history of the red planet. Mars is a dead world today, or so we think. But what if it wasn't always this way? What if, millions or even billions of years ago, Mars was home to an ancient civilization that was wiped out by a cataclysmic event? Rocket, could we be the first intelligent beings on Mars? Or are we just the latest visitors? Keycap 5, the case for an ancient Martian civilization. Clues in the landscape. Microscope scientific insight. Mars wasn't always the barren desert we see today. Studies from NASA's Curiosity and Perseverance rovers confirm that billions of years ago, Mars had rivers, lakes, and possibly even oceans. If life evolved on Earth in such conditions, why not on Mars? Magnifying glass tilted right, possible clues of a lost civilization. The face on Mars. In 1976, NASA's Viking 1 orbiter captured an image of what looked like a massive human-like face on Mars. While later images revealed it was just a rock formation, many still speculate that it was part of an ancient structure. Martian canals. In the 19th century, astronomer Giovanni Schiaparelli observed what he called canali on Mars, linear structures that some believed were artificial waterways built by intelligent beings. Hexagonal and symmetrical patterns. Images from Mars reveal unusual geometric formations that don't appear random. Could these be the remnants of artificial structures eroded over millions of years? If an intelligent species once lived on Mars, where did they go? Did they destroy themselves, or did something else wipe them out? Speech balloon, do you think we might one day find ruins of an ancient civilization on Mars? Tell us in the comments. Keycap 6, the Great Martian Cataclysm. What could have destroyed an ancient civilization? If life, and possibly civilization, existed on Mars, what cataclysmic event could have erased all traces of it? Microscope scientific insight. One leading theory is that Mars lost its magnetic field around 4 billion years ago. This caused the planet's atmosphere to be stripped away by solar winds, leading to the extreme cold and dryness we see today. Rocket, possible causes of Martian extinction. Mega impacts. Mars shows evidence of massive asteroid impacts, like the Hellas Basin, which stretches over 2,300 kilometers. Could a colossal asteroid impact have triggered a nuclear winter, wiping out life? Nuclear war? Some researchers, including physicist Dr. John Brandenburg, controversially suggest that isotope readings in Martian soil resemble those found in nuclear detonations on Earth. He proposes that Mars may have experienced an ancient planetary war or nuclear catastrophe. Volcanic apocalypse. Mars Olympus Mons, the largest volcano in the solar system, suggests intense volcanic activity. A planet-wide volcanic event could have filled the atmosphere with toxic gases, suffocating life. If Mars was once home to an advanced civilization, could their destruction serve as a warning for humanity's future? Keycap 8, what will humans look like after generations on Mars? If humans settle on Mars, we won't just adapt, we'll evolve. Over thousands of years, the unique conditions of the red planet could shape an entirely new species of human. But what changes would we see? Would Martians still recognize Earthlings as their distant relatives? Gravity's effect on the Martian body. Mars has only 38% of Earth's gravity, meaning everything from bone structure to muscle density will change over time. On Earth, gravity constantly pulls on our skeletons, keeping our bones strong. But in low gravity, bones and muscles weaken and shrink, leading to a taller, thinner body. The heart and circulatory system adjust to lower gravitational forces, possibly making Martians more prone to cardiovascular issues. The body's overall structure could become more fragile, with longer limbs and a larger head-to-body ratio, similar to astronauts who experience microgravity effects. How radiation could alter our DNA. Without Earth's thick atmosphere, cosmic radiation bombards Mars constantly, damaging DNA and increasing mutation rates. Over thousands of years, humans might develop thicker skin or denser melanin to shield against radiation, smaller eyes, or even protective membranes to handle increased UV exposure, a stronger immune system to fight off the harmful effects of radiation on cells. Some scientists speculate that, to survive long-term, humans may need genetic engineering, using CRISPR technology to edit DNA and make future Martians resistant to radiation. The birth of a new human species? If Martian settlers remain isolated from Earth for tens of thousands of years, the evolutionary changes could be so extreme that they become a completely new species, Homo martianus. They might have bigger lungs to compensate for lower oxygen levels. They could evolve larger brains as they develop unique cognitive skills to survive in an alien environment. They may even develop red-tinted skin from higher iron exposure in the Martian soil. At some point, would Martians and Earthlings still consider each other human? If they evolved separately for millions of years, would they even be able to interbreed? Speech balloon, what do you think future Martians will look like? Will they resemble humans or something else entirely? Drop your thoughts in the comments. Final, the future of human evolution on Mars and beyond. Humanity stands on the brink of becoming a multiplanetary species. As we prepare to colonize Mars, the Moon, and perhaps even exoplanets, the question isn't just how we will survive, it's how we will evolve. Evolution isn't just a relic of the past, it's an ongoing process. Over thousands or even millions of years, humans living in radically different environments will transform in ways that could redefine what it means to be human. A fork in the evolutionary road. Once humans settle on Mars, their physical and genetic adaptations could make them drastically different from Earthlings. Over generations, lower gravity, intense radiation, and a limited ecosystem will shape them into something new. Martians may grow taller and thinner, their bodies no longer needing to support heavy gravitational loads. Their skin might darken or develop new pigments to shield against radiation. Cognitive and sensory abilities could change, adapting to a world with weaker sunlight, extreme temperatures, and artificial habitats. At some point, will Mars-born humans be so different from Earthlings that they can no longer reproduce with them? Could we witness the birth of a new species like the evolutionary split between Neanderthals and Homo sapiens? The role of technology in evolution. Unlike past evolutionary shifts, modern humans have technology that could accelerate or even control the process. Genetic engineering could allow us to preemptively adapt to Mars before natural evolution takes its course. Cybernetic enhancements, such as bionic limbs, augmented vision, or brain-computer interfaces, could make adaptation an artificial rather than a biological process. AI and robotics could influence human society so deeply that evolution shifts from biological survival to technological integration.